We're Group 7, and we are Project Fan. Our group consists of Hunter Stokes, Tristan O'Sullivan, Wade Maurer, Ryan Shepa, and Joseph Shepard. For our table of contents, we have, for our first couple slides, it's our intro to our project. Then we get into the breakdown of the project. Then we move into your results and discussion, and then we finish up with our final results and some further improvements that we can make later down the road.
Introduction of Project Fan. Background. Like our Ratliff Relay project, we chose a PC fan design based on our belief in an optimization and efficiency ideology. Inspiration. We all have a PC that is unreliable. The main issue comes down to overheating and inefficiency of the fans. Our goal is to make the most efficient PC fan that will keep your PC cool and running to its fullest capabilities. Motivation. Overheating affects performance, reliability, and component lifespan. Increasing power in PC demands better cooling solutions. Problem statement. Current fans are noisy, inefficient, and have poor airflow. Need a quiet, efficient fan for high-performance cooling. Solution overview. Enhanced materials and motor for quieter, efficient cooling. And a small design to accommodate for space.
Breakdown of Project Fan. So our fan has 5 main components, and to each component we added certain things to make it slightly better. So for the housing of the fan, we added internal dampening pads. To the fan hub, we made it slightly heavier to try to reduce vibrations and shaking noises. We used a very aerodynamic shape for the fan blades. We created a motor mount to securely attach the motor to the back of the fan blade, and then we added a back plate to improve the stability. Now, to print all of this stuff, we would use a PLA plastic. It's supposed to be very rigid, and it makes it very structural, keeping our fan lightweight while also extremely strong.
Results and discussion, testing and prototyping. When we were testing, we found out that an X piece and a smaller, more efficient motor really helped the efficiency with cooling. Our models show that our added piece and implementation of the new parts help the design to look more professional and help lower noise. Virtual prototype, the model. This is the prototype our team selected as the final design. After evaluating multiple options, it showcases the culmination of our engineering expertise, highlighting our commitment to innovation, precision, and functionality. This model represents the best balance between efficiency, durability, and performance that we aimed to achieve throughout the project. Discussion. In our design, we had less than optimal results due to printing errors. However, the fan blade and housing were strong and stable under high revolutions. The hole for the motor collapsed due to its small size. What we found that was interesting with our final model was how solid the fan blades were, despite how thin they were. When spinning, the product was optimal in sound produced by the fan.
Conclusion of what we learned. As we've worked on this project, we have learned that when building a small, detail-oriented build like this fan, it is important to have 3D printed material that will be able to correctly make those adjustments and prints. A better material would make our fan blade smoother and more effective. What next? It is important to us that we are also able to plan out a better model strategy for future builds. Having a set plan for how we are building will massively help efficiency. Benefits. As students, this project has greatly helped our understanding of project planning as well as developing our 3D modeling skills, a very important and practical skill for our futures. The future. At this stage of the project, our focus remains on creating as many prototypes as possible to develop a project that maximizes efficiency in 3 key areas: thermal regulations, acoustics, and compact size. So far, the main lesson learned has been in time management, as we have encountered some challenges with coordinating schedules and workloads among group members. Moving forward, we plan to optimize and improve our 3D print using better materials that allow the fans to properly move how they're supposed to. Our expected outcome is to demonstrate improvement in at least one of the categories mentioned, in thermal regulation, acoustics, or compact size.